Okay, now let's look at question number 13 of the pure paper and part A of that. So what is given to us? It's given that A is a real number and a 2 by 2 matrix is given. Capital A matrix is 1A minus A1. First part we want to show is that A inverse exists and then we need to find A inverse. So for a inverse matrix to exist, the determinant of A matrix has to be non-zero. So if the determinant of A is non-zero, A inverse exists. So we have to show that condition for the given matrix. So let's find the determinant of A. So determinant of A is what? We multiply along the diagonals. So 1 times 1 minus along this diagonal now. Minus A times A. Minus A times A. So what do we have now? 1 plus A squared. So this is obviously greater than 1. So that means determinant of A is non-zero. So that implies A inverse exists. So the inverse matrix of A exists. Now we want to find the inverse matrix. So let's try to find the inverse matrix. So let's recall the formula for a 2 by 2 matrix inverse. So A inverse is given by 1 over determinant of A times this diagonal elements, you flip them. D goes to A's position, A goes to B's position. And the elements in this diagonal just multiply by a minus sign. So that will give you A inverse. So using that formula, let's write down A inverse. So for this question, determinant of A, we found 1 plus A squared. So 1 over 1 plus A squared times these two elements, we have to flip the order. So 1 goes to 1, 1 goes to 1. So there's nothing to change there. And each element in this diagonal has to be multiplied by a minus sign. So minus A. So if we want, we can put the constant outside inside into each term. So we will get 1 over 1 plus A squared. Then the second term is minus A over 1 plus A squared. Then in the second row, first term is A over 1 plus A squared. And second term is 1 over 1 plus A squared. So that is the A inverse matrix. Right. Then the next part is we have been given this B matrix and we want to find the value of A such that A inverse B transpose is going to be equal to this one. A inverse B transpose is going to equal to this given matrix. So instead of finding A inverse and multiplying with it B transpose, we can do something like this. because if we made a mistake in finding A inverse in the previous step and we multiply by a wrong matrix here, this question is also going to be wrong. Instead of that, we can do this. We can multiply both sides by matrix A. Then what happens here? A times A inverse is identity matrix. Identity matrix times another matrix is that matrix itself. So we have here what is A matrix? A matrix is 1A minus A1. 1A minus A1. And let's put this minus 1 over 5 inside. So minus 1 over 5, 3 over minus 3 over 5, plus 3 over 5, minus 1 over 5. And this side is going to be what? B transpose. And let's multiply these two matrices. You get what? Minus 1 over 5 plus 3A over 5. Then minus 3 over 5 plus, sorry, minus 1 over 5A. Then in the second row you get minus A over 5 times minus 1 over 5. So plus A over 5 plus 3 over 5. Then we, for the last element, you multiply this row with this column. So minus A times minus 3 over 5 becomes plus 3A over 5. Then 1 times minus 1 over 5 becomes minus 1 over 5. Okay. Then from here, what is B transpose? B transpose is flip the rows and columns. 1, 1, minus 1, 1. So that is B transpose. So 1 minus 1, 1, 1 is equal to this matrix. 3A minus 1 over 5 minus A plus 3 over 5 plus A plus 3 over 5 3A minus 1 over 5. So if two matrices are equal, each element is equal. So this element is equal to this element. This element is equal to corresponding element on the other side, and so on. So we can now, let's equate the first element in each matrix. So you get what? 1 is equal to 3A minus 1 over 5, or 5 is equal to 3A minus 1, 3A is equal to 6, or A is equal to 2. So that is our answer. You can double check by just plugging it into this element. So if I plug A equals to here, 5 over 5 is 1, which is what we want. Here you get 5 over 5 and minus sign, minus 1 is correct. And here you get plus 1, plus 1. So this is correct.